Type 2. So we're talking about vertical motion. Remember, with vertical motion, the acceleration is equal to 9.8 if it's falling downwards and minus 9.8 if it's being projected upwards. There's a time delay between these the particles in these questions as well. So just remember, the particle that's projected first will have a longer time associated with it. Obviously, then the particle that comes second has a lower time. Alright, so the question we're looking at is 1F question 4, reads, a stone is thrown vertically up with a velocity of 25 meters per second. 3 seconds later, a second stone is thrown up with a velocity of 20 meters per second, and then the stones collide. We're looking for what height do they collide. So particle 1 is travelling along that path. It's thrown up. Particle 2 is also thrown up, so the only way they're going to meet is if particle 1 is on its way down and particle 2 is still on its way up. So particle 1 travels along that white path, particle 2 will travel along that pink path, and they'll meet where the dotted line is. Remember that the displacement in this case is the distance from the start to the end only. So the displacement for both particles is equal to the length of that pink path. The displacement is equal to the length of the pink path. So I'm going to use S is ut plus a half RT squared for the particle that travels along the white path and the particle that travels along the pink path, and equate those. Okay, I forgot to mention or remind you that the particle that travels along the white path, I'm going to say that it travels for time t. So the particle that travels along the pink path is fired 3 seconds later. It's travelling for 3 seconds less. So the time taken for it to collide with the other one is t minus 3. Okay, we're all set to go then. S is ut plus a half RT squared for the first particle. For the second particle, note that t minus 3 is subbed in for the time there because it's travelling 3 seconds less than the other one. So we have two formula for S, equate the two of them, solve for t. When we solve for t, we get 4.27 seconds for them to collide, and if you put that into either of the S formula, S1 or S2, you'll get a distance that you'll get a displacement that each particle has travelled of 17.5 meters. Right, that's the end of question 2. We'll have a third video in a moment.